the format of this is I will cover the use case from moving from a SQL database to a Postgres database platform using our tool. So to start off, what I've done is I have a model here, a logical model and a physical model that was created by reverse engineering a SQL database. Now, the SQL database was created in SQL Server 2000, and you can see down here at the bottom, it says Microsoft SQL Server 2000. So you know which platform it is based on what you have, what's listed down at the bottom. So what I want to do is I want to forward engineer this into a Postgres model. And with ER Studio Data Architect, with this tool, it's very simple to do this. Because you have the ability to create multiple physical models in the same model file, not only can you create another physical model based on a different platform, but this also allows you to handle your data lineage for that as well. So to get started, what I prefer to do, instead of just changing the platform here, you can go here to model options, and you can change the actual model platform if you wish to a different platform. But I want to maintain the existing model because I haven't deleted it yet. It's still out there. So I want to maintain that. And I also want to document how that data is going to transform and move from the first database to the next database platform. So to do that, what I'm going to do is I'm going to right click on the logical model and I'm going to generate the physical model. Now here's where I, excuse me, here's where I can choose which platform I want to select. And for this demonstration, we're going to use Postgres. So in 18.3, we've not only brought Postgres up to currency, but we also have the ability for you to not just reverse engineer Postgres through an ODBC connection, but also compare what you have in your model, any changes that you have in your model, and then push those changes or the entire database structure out into your Postgres database. I'm going to choose PostgreSQL, and I'm going to title this Postgres. Say data migration. And click next. Now here's where I get to choose naming standards template if I have one. I can also apply a global prefix if I want, or a global suffix, or retain the current owner names, which I will. Click next, and I can also specify a storage space for this if I have that information in my database. Click next, and then I can also specify how I'm going to handle non-specific relationships. Now clicking next, what this is going to do, one of the names is invalid. It's a convert situation. So these are all rules that I have in the database. So these are not supported in Postgres from SQL to Postgres. So I'll just click through these so that it won't bring those rules in because the nomenclature is different for Postgres. So those are something that I'll have to review later if I want to maintain those same rules. Now, once I have this database or model, this physical model in my database, then I can then create data lineage, and I can do this data lineage documentation via visual data lineage down here in the tab while that's spinning and bringing that over. I can go here to the data lineage tab and visually represent the ETL work that needs to be done, or I can do column level data lineage, which I'll show you. Now, each of these can be brought, all of this information can also be brought in via Excel through a macro, if you wish. And you can also, for both visual data lineage as well as column level data lineage. Not really sure why it's taking so long. I have this out on a VM, so it's quite possible that I may be lagging there. I have another method to do this if I need to. My apologies. I'm just going to let this spin for just a second, and then I'm just going to go to the other method. That's a good question. The question is, shouldn't we keep track of the settings that we have in the model that aren't supported by Postgres? Absolutely. And I would just click OK because I wanted to get on with the demonstration. But what you typically do is you would write down those specific rules. And because you're not changing the original physical model, you're just adding another physical model to it, you still have that documentation from your original original physical model in the same model file. So that's another reason why I don't like overwriting something or changing the original, because that way you can always go back to it. Now, if you have the repository, you can also branch this or create another version. So that way you can still go back and you can compare against what you have in the repository. The repository comes with the professional edition as well as the enterprise team edition. And the repository is essentially a source control system. It's a database that sits out in your environment, whether it's a SQL Server instance or an Oracle Server instance. Question: can the repository be set up in a Postgres instance? No, it cannot at this time. We have in the roadmap to support Azure SQL database as a backend platform for the repository, but not Postgres. All right, it's finished. So now we have a Postgres data sort or physical model, as well as a SQL physical model. Now inside here, if I click on one of the tables, if you notice, it also inherited the view of the logical model. But if you look at the main physical model, it's got it all blown out. So to change that view, I can just simply right click on this, go to my diagram and display options here, and I can choose to show all of the information. I'm going to go to table and show physical attribute ordering, and don't order anything else. You know what? I do want data type. I'm going to show that. Might get a little busy, but we're going to show it anyway. Change the layout here. Kind of move these around so they're a little bit more clustered here. And do this again. Oh, let's do that one more time. Oh man, why is it making it so small? Maybe I'll change another layout. It makes sense to have it down here. All right, so we'll zoom in a little bit. Now, in here, if you notice, the data types have all changed. Now, what we don't have in this yet is JSON, and that's coming in the next version as far as a data type. So to get around that, what you can do here, one of the major features that makes this tool so flexible is that you can actually go in here to this data type mapping editor, and you can add any additional data types you wish. So if you notice down here, it's all in alphabetical order, but there is no JSON. So what I'm going to do is I'm going to add a new custom data type, and I'm going to call this JSON. Now you can put it, nice, Jason. You can put in whatever one you want. So I believe there's another JSON B, I think, or JSON A, I can't remember. It's been a while since I played directly with Postgres. But there are a couple different JSON data types that you can use. So I'm going to base this off of time. It was a character varying, I think. I use that. And I'm going to use, for this one, I'm going to use, not image long varchar, ntext long varchar, okay? So now JSON is in there, but its physical mapping is character varying. So what I'm going to do is I'm going to double click on this, and I'm actually going to, add a new physical mapping. So I'm going to call this one JSON too, JSON as well. Okay, I'm going to base it on the logical JSON and say okay. So now JSON, if you reverse engineer Postgres and there's a JSON data type in there, it'll map that to a JSON physical data type. Okay, and then I'll just click OK. I want to replace it. Yeah, that's fine. So now in here, if I go into a particular table, and maybe I want to change this from character varying to JSON, I can click down here. And why is it not there? Well, that's unfortunate. Hold on just a second. If I add a new one. Let me see here. So it's in there. So let me go back to the data dictionary. Now in the data dictionary, you have this ability to also include user data types. So I'm going to create a new user data type, base this off of a particular base type. I wonder if it just didn't refresh. It seems like it hasn't. Sorry, I'm thinking out loud here. I'm going to call this JSON as well. And say okay. So now if I go into orders and I add another field, or now I have JSON. Bloop. All right, we have another question. The question is, if that's a good solution to add a custom data type for JSON, why didn't you just include that in the data type mapping template? And that's a really good question. I would imagine that was a decision that was made in the development team's realm, so I'm not sure why it wasn't included. I know that Postgres has a lot of different data types, and of course they had to make choices on the fly of which data types they were going to include in the product before release, and JSON just didn't make the cut, I guess. As soon as we're done with this, I'm going to talk a little bit more about the data lineage, because I'm sure you all are very interested in how to document that and how to move your process forward through your data pipeline. So, I wonder if I can open up another one. So what I'm going to do is I'm going to do exactly what I already had created. I'm going to reverse engineer an existing database. I'm going to, actually, no, I'm not. I'm going to go into the repository. So let's go into the repository. I'm going to log in. Now again, this repository is a source control system. Again, it's just a database, holds all of your modeling information. What this allows you to do, it allows you to share your diagrams with the rest of your team. So people can check in and check out models. They can do it concurrently by default or exclusively if they choose. So that way no one else can make changes while they're making changes. You can also associate particular projects in here with JIRA. So when you check something out, an object inside of a project that's also associated with a JIRA project, when you check that out, there's a dialog that'll come up and ask you for a change record as well as a description. And there is also a task dropdown. So if that object is associated with a JIRA project, then you'll have the list of tasks that you can associate that change with. I'm going to go to diagrams and I'm going to get from the repository. I'm going to get the Northwind DM1 file. I don't know why I expanded that. Now here you can, like I said, you can check it out immediately. You can also check it out exclusively. I'm going to check it out immediately. No one else is in this, so I don't really have to worry about it. And it's just saying that the version I have on the computer is different from the server. Do I want to override it? And I said yes. All right, so as you can see, I have loads of different locks here, very similar to the one I was just playing with. All of these locks and, well, unlock icons show that it's been checked out. So visually, I can see that this has been checked out. And I also have Northwind SQL Server. Now, this one was used to demonstrate the migration path from SQL to Oracle, which is very similar to doing the same thing for Postgres. Now, what I would do is, just like before, I would take my logical model and I would convert it to a Postgres model. And let me slide over here and see if this is done spinning. And it is. So in the data model, what you would do to document your data lineage. Now I've gone back over to the other one. I don't want to lose y'all, but I've gone back over to the other one to show you how your data lineage would work. Now in the data lineage, what you would do is, this is your destination. So for column level data lineage, you want to show how each specific column is being handled and populated. Okay, so I'm going to go to the data movement properties for my Postgres project, and I'm going to specify the source. Now the source for this, of course, is the Northwind SQL database, and I'll just say OK. So now that I have that set up, to document a column source, I just double click on the table, go into one particular column, maybe required date, and I'm going to copy this because I'm going to use this in the comment section. Excuse me. So I'm going to go over here to the data lineage tab, and I'm going to specify that this is coming from orders over in the SQL database and our required date. And maybe I've done a trim, or maybe I've done a convert on this required date. And then the transformation description, what's a trim do? It just removes leading and trailing spaces, right? Then I say OK. So now when someone clicks on this column, they can see exactly where this came from, how it was handled, and why it was handled that way. You can do the same thing with any kind of aggregations or splits or concats or anything like that. Okay, so what this does, this allows the business user or software engineers or any report writers to understand why their report isn't working, or it gives them more context around the source of their information that they're looking at. All right, now that's column level data lineage, and you can import that again, like I said, with macros. Yeah, this has got to be my VPN because this doesn't spin like this on my computer. Now, through macros, I'm going to go to the other instance. That's ridiculous. Now, through macros, what you can do here, out of the box, we have these sample macros, and they're broken up into sections: metadata management macros, as well as model layout macros and model productivity macros. The model productivity macros are essentially your conditional formatting and so forth, and adding foreign keys based on the name of the table and so forth. These are all written in WinWrap Basic, so if you know Visual Basic, you'll know this. The one that I'm wanted to point you out to is the visual data lineage import and export from Excel, as well as the data lineage. So the data lineage is the column level data lineage that I just did, and you can import and export that via Excel as well. So you can do that all in batch. You don't have to do that in a onesie-twosie method like I just showed you. Now, as far as visual data lineage, if you click down here on the tab called Visual Data Lineage, let me expand that a little bit. To document this, you can use this as a requirements document, or you can document your existing ETL situation. So we have the ability for you to import various ETL tool files, tool files. And we support Informatica right out of the gate, as well as SQL integration services, SSIS. So what I'm going to do is I'm going to use this to document a move for item. Okay, so this is just to visually represent what's happening with the ETL to populate item. So item is in my physical model, which is the, because I don't have the other one because it's not showing. Oh, that's why. Okay, so let me go back to data lineage. So in here, in this data flow model, oh, for crying in the sink. Oh, I know why. I'm on my own computer. Sorry, everybody. So let's go to data lineage. I'm going to create a data lineage for, let's do shippers. ETL underscore shippers. Okay. So I have my different sources. This is my Northwind. That's the source that is coming from. I'm going to use the table here, slide that over. And it's going into a destination here for the Postgres project, the migration project here. And I'll slide that over. Now up here is a transformation tool or a transformation control. And that's where the key documentation for this process happens. This is just a data stream, so I can document the direction of the data flow here. And then double clicking on the transformation, I can give this a name. So maybe there's a store procedure running. Store procedure is called shippers. And now I can specify my columns that are being brought over and where those columns are going to. Now, just because you have it's pretty self-descriptive, right? Shipper's company name is going in company name, phone is going into phone, but you can have multiple columns over here or multiple columns over here and have it lopsided, and you don't really know directly through this mechanism, through this visualization, what columns are going to which columns. So you can provide additional definition here. Now, the business definition and the code definition, these are all just suggestions of what kind of information you want to put in there. They're just text boxes. There's no validation that's happening to this. This is just a way for you to add additional context around what is actually happening in this ETL, or what you expect to happen in this ETL when you pass this over to the ETL developers. So you're using this as a requirements document, or you're using this as a documentation for what's already existing, what have you. That information would go into these objects. So for business, typically what I suggest is putting in the name of the file, how often it's run, who's the owner of this ETL package, source to target information, that kind of thing. When it was the last run, those kind of things. What's the schedule for that? And as far as the code, what I would suggest is this is where you would handle your column to column mapping. So, column A equals column A equals column A, similar to that. Or if you have any kind of splits or concats or anything like that, I would document that information here. Now, as far as data movement rules, you can also include those. You would create your data movement rules up here in your tree view over here. So if you have an append, a delete, a conditional update, those kind of things, you would put that information in those rules, and then you could apply that to this transformation. And then, of course, you can also have attachments. Attachments are essentially notes that you would have in your data dictionary, and you can apply those here. Now I'm going to say that this is a direct map and say OK. All right, so now you have a visual representation of an ETL process that either needs to be put in place or is already in place. Now, if you want to document something that's already in place, you can go here to import file, and you can bring in from external metadata. Now, these are included in the Enterprise Team Edition. You have a number of bridges that allow you to connect to various sources, not just database sources, but also reporting or visualization sources and ETL, like I discussed earlier. And of course, if we don't support a particular platform that you're looking for, you have the ability to export from that platform into JSON or ETL or XML or CSV, and we can ingest that as well. Now for your ETL, like I said, out of the box with Enterprise Team Edition, you have the ability to go to, say, Microsoft SQL integration services, and you can connect to a file or a repository database or a repository file, or even the DSV file if you wish. We also have the ability for you to connect to, come on, drop down. You'll have the ability to connect to Informatica as well. And this is all documented on our website if you want to go take a look at the different bridges that we have. As for visualizations, the big heavy hitters are, ClickView and ClickSense. A lot of people are going to the web visualization providers, as well as Tableau. Now we're also coming, probably notice Snowflake here as well. I don't want to go into anything off of Postgres, but the Snowflake capabilities, the full Snowflake capabilities that you also have in 18.3 with Postgres, those capabilities will be coming in 18.4, which comes out later this fall. Right now, we have the ability to reverse engineer from Snowflake. So if you have stuff in Snowflake, we're talking about Postgres though. Let's go back to that. So I have my Postgres model, and I've created my model, but I don't have a database out there yet. So what I would do is I would right click on this, and I would select to generate database. Now this is going to generate a SQL file. If I go to the end here, it's going to create a .SQL file here, and it's going to be placed out in this default location, which I can change in tools options as well. And these are the different objects or the different components of that SQL script that I can also include if I wish. Clicking next, I can then select all of these objects because I've already selected those objects, and I can get some additional key components for what it's going to actually generate. Now, if I go to SQL Preview, I don't want to do that. I want to click Finish here. You know what? Let me do that again. I went the wrong way. Generate database. Create my file. Go on through. Click Finish. Do I want to overwrite it? Yeah, let's do that. All right, so here is where it will create my SQL file. I can take a look, make sure that everything looks good in that, and then I can share this off to a shared location where my DBA can pick it up and run it directly on the database if I wish, or through a DSN, I can define a DSN based on my Postgres ODBC, and I can connect directly to that. Now, DBAs don't like hearing that, of course, so they have additional securities in place. But if this is a database that you have jurisdiction over, you can create a DSN and connect directly to that. And then that opens up a wide variety of options. Through this universal iSQL tool that we have inside this tool, you don't have to have a database management utility, a separate database management utility that you're using. You can run simple queries directly from this, and this allows you to interrogate your data that's over in source database or something along those lines and understand what the data components, what the actual data is in each particular column. And then you can annotate that through your documentation. Otherwise, what you would do is you would save this off to a file location where your DBA can pick it up and run it. Now, as far as changes, you already have a Postgres database. You've created your Postgres database. Now you want to change it. What you would do is I'm going to do a new one, but this time I'm going to reverse engineer my Postgres. So that way I know that I actually have a Postgres database out there. And I'm going to reverse engineer that. So I'm going to create a real Postgres model that's connected to a real Postgres database instead of this model that's not connected to anything. Okay, so I have this real Postgres database. This is a model that I've generated from the Postgres that's out there. But here, what I'm going to do is I'm actually going to make a change. So I'm going to go into address and add another attribute here. I didn't create domains. That's a bummer. So maybe I'm going to add a title. It's going to be a car 10 and say, okay. Now I've made a change to my model and I want to maintain my model. I didn't do that in the physical model. Let me do that again. Address. Notice that the names have all changed. It's because there's a naming standards template in here that enacts that. So I'm going to add this here. Again, add a title. And this is going to be character 10. But I'm going to say char 10. Say OK. All right. So now I want to move that change over into my database. To do that, I'm just going to right click, go to compare and merge utility, and I'm going to compare this to my live database. Compare against the live database. So with the other additions, I have the ability, with the base edition, I can compare against another model in this DM1 file or against another model in another DM1 file. But with the professional as well as enterprise team edition, I can also compare against a repository-based DM1 file. So if I have a DM1 file that I've branched from or that it's got another version, I can compare against that other version and see what the changes are, what the differences are, and I can script that out and pass that on. Or I can compare against another SQL file that was written out for me. So if I don't have jurisdiction to a particular database, the DBA can script it out for me, and I can compare against that. Clicking next, just put in my password here. And it's just going to default to the database that I already have defined in my ODBC connection. These are the different objects I'm going to compare. I'm just going to compare address for conciseness. Now notice here that address pops up. These, if I drill down, I can see all the differences. The reason these ones have come up as differences because obviously since I put the column in the middle of the file, the sequences are all going to be different. So I'm going to move that change over into my database, merge to target. Now here's where I can specify, I can report out the suggested changes, and I can report this out into an HTML or an RTF format. And then this can be submitted along with the expected SQL code that I'm going to generate in a second. And this can be submitted up the chain of command for you to get sign off, for it to be QA'd prior to implementation. Now clicking next, it's going to generate this SQL for me. Yeah, let's say yes. All right. So now, because I've added the column to the middle of the table, it's going to do a number of things. First, it's going to rename the old table, create a new table with this new field here. And then, just like it does with any other platform that we fully support, it's going to take that data from the old table and move it into the new table. And then it's going to add the constraints back on. Okay. And again, just like before, you can connect if you have jurisdiction over this database, you can connect via DSN and you can run it directly from here. Or again, if it's part of your process to get QA'd, then you can save this off to a file location. DBA can QA it and submit it after it, or run it after it's been approved. So we have a question. Why doesn't it export to an Excel format? That would be so much more useful than RTF. Yes, I agree. But what we also have is the HTML format, and I can show you that format right quick. Let me do another compare and merge. In fact, I'm sorry for glossing over that. Yeah, Excel or CSV even would be helpful. In fact, that's a great suggestion. In fact, and I will submit a change ticket for that. So I'm going to move this into my target, and I'm going to click report. So here you have the RTF or an HTML report. I'm going to choose HTML because I prefer it, and call this changes. And we can see what this looks like. So this is your suggested changes that you're going to make by moving that into the target. And of course, this is in a very similar format to a CSV or an Excel. So I don't think it would be much of a problem to take this information, copy it, and put it into an Excel spreadsheet. Just a simple added step. All right. So to recap, the process for moving from one physical model to another physical model would be to start with your logical model, right-click, generate that physical model for your next platform, whether it's Postgres or any of the others that we support. And these are all the different ones that we support. Obviously, I'm highlighting Postgres because we just added that. Previous to this, we also added Redshift, and next in line, of course, is Snowflake, and you'll be able to do the exact same thing. Now, once you've created your new physical model, you can then, through data movement properties, you can specify your column level data lineage, as well as going into your visual data lineage and representing what is expected for the ETL work that needs to be done for making that move from your previous platform to your new platform. I appreciate your attention, and I hope to talk to you all again soon.